Hello, this is KHURRAM Nasir and you're watching Optometry with KHURRAM, and finally we have started a new chapter of Optometry, a new playlist of Optometry called contact lenses, right? So you know very well that what is the definition of the contact lens. Contact lens is actually a device which insert on the anterior surface of the cornea. So we have so many types of contact lenses, like we have soft contact lenses, we have RGPs, rigid gas permeable contact lenses, and we have scleral contact lenses. We have so many types of contact lenses we will discuss in the upcoming videos, but in this specific video we will learn about the different basic parameters of the contact lens. Like we will discuss about the diameter, base curve, sagittal height, etc. Right? So before learning about the different parameters, let me tell you some important terminologies. The steep fit. Remember that the steep fit contact lens is also called the tight fit, right? And the flat fit is also called the loose fit, contact lens. If the fitting of the contact lens is loose, right? And the normal fit is also called the ideal fit or the proper fit of the contact lens. So what? Steep fit is also called the tight fit, flat fit is also called the loose fit, normal fit is also called the ideal fit, and the proper fit. The most appropriate term for the normal fit is ideal fit contact lens, right? So remember that what is actually the steep fit. Remember, for example, if this is the eye, this is the lateral view of the eye, right? And this is the eye, and if contact lens is like this, the contact lens is like this. For example, the distance between the cornea, this is cornea, and this is the blue is in the contact lens. The distance between the cornea and the contact lens is so great. There is a big difference between the cornea and the lens. So if the gap is larger than the normal, so this will be the steep fit or the tight fit, right? And the contact lens will tightly adherent from the peripheries, from here, right? So this is called the steep fit or the tight fit. And in second example, for example, this is the eye, and if the contact lens is you see the edges are flat, these edges are flat than the normal, right? And there is less space between the cornea and the contact lens. So this is called the flat fit or the loose fit. And last one, the ideal fit. This is eye, and if the contact lens is exactly settled on the surface of the cornea, this ideal fitting is called the ideal fit or the proper fit or the normal fit. And now finally let's discuss about the different parameters of the contact lens. First of all, we'll discuss about the most important parameter, and that is called the diameter. The diameter of the contact lens. So diameter, exactly, the crude definition of the diameter is actually the width of the contact lens, right? The widest part of the contact lens. So what does it mean? For example, if I look the contact lens from the frontal surface, so contact lens is like this, and if I see the contact lens from the lateral side, the contact lenses look like this. So we will discuss about the diameter. So I tell you the definition of the diameter. The diameter is actually the widest part of the contact lens, the widest width of the contact lens. So that is called the diameter. So the diameter of this contact lens is, this line is actually representing the diameter of the contact lens, the widest line of the contact lens, right? So this is the diameter, the widest width of the contact lens, right? So in this contact lens, from the lateral view, the distance between this point and this point, this is called the widest part. This is called the diameter of the contact lens, right? So let's discuss some more important points regarding the diameters of the contact lens. The diameter of the contact lens depends upon the diameter of the cornea, right? The larger the diameter of the cornea, the larger will be the diameter of the contact lens, right? And the next thing is the diameter of the contact lens depends upon the palpebral fissure or palpebral aperture as well. You know very well that the distance between the upper eyelid margin and lower eyelid margin, the distance between these 2 points is called the palpebral fissure or the palpebral aperture, right? So the things which can affect the diameter of the contact lens are the diameter of the cornea, number one, and the palpebral fissure or palpebral aperture, right? And the next thing is the HVID. HVID we will discuss in the upcoming videos, but I will give you the brief introduction of the HVID. HVID is actually the horizontal visible iris diameter. So horizontal visible iris diameter. So for example, if this is the eye, this is the eyeball, and this is the iris, you know, the colorful structure of the eye, right? So we'll get a scale, and I will put a scale like this, and I will measure the distance of the iris width from this point to this point, right? So this width is called the HVID, the horizontal visible iris diameter, right? So for example, if I get HVID of 11, for example, this is a supposed value, then this is the value of HVID. 11 is the value of HVID. I will add 2 in the 11, and that will be the 13 will be my diameter of the contact lens. So I will choose the diameter like this, right? So as I told you that the widest part of the contact lens is called the diameter, right? So now we will discuss that if I increase the diameter or if I decrease the diameter, how this increase or decrease in the diameter of the contact lens can affect the steepening or flattening of the contact lens, right? So for example, let me give you the concept, the basic concept. For example, this is the diameter, and the diameter is, for example, 10, right? And this is the contact lens, and you know that this line is called the diameter, right? And the value of diameter is 10 millimeter right now, right? And for example, if I increase the diameter, so what is the diameter? This blue line is actually represent, this line is actually representing the diameter, right? So in this case, I increase the diameter, this line is smaller and this line is bigger than this one. So I increased the diameter. So right now the diameter is 11 millimeter. Diameter is increasing actually, right? So if I increase the diameters, the lens will be more steeper. You see the curve is being more steeper. Right now in less diameter, you see in less diameter the curve is less steeper. The contact lens is flat, right? If I increase the diameter, you see the contact lens is now more steeper, right? And if I increase the diameter more than the 11, so for example, at this point, you see the line is bigger than this one. So for example, if the diameter in this case is 12 millimeter, so you see the curve will be more steeper. The lens will be more steeper. So we conclude that if I increase the diameter of the contact lens from 10 to 11, 11 to 12, the lens will be more and more steeper. So we conclude that if we increase the diameter of the contact lens will be more steeper. You have to recall, you have to remember this key line, that if we increase, so for example, the diameter, if I increase the diameter, the lens will be more steeper. The lens will be more steeper. The lens will be more tighter fit, right? So let's discuss another parameter, important parameter, which is actually connected with the diameter, and that is called the sagittal height. So sagittal height is actually, remember that this is the flat surface of the lens and this is the curved surface of the lens. You can imagine, right? So the distance between the flat surface of the contact lens and the curved surface of the contact lens, this height, this distance, so these heights are called the sagittal height. And you can see very well that in 10 millimeter of diameter, when the diameter was less, the sagittal height was less. When we increase the diameter, you see the sagittal height is increasing accordingly. In this case, when we increase the diameter more than 11, 12 millimeter, the sagittal height is increasing accordingly. So we conclude that if I increase the diameter of the contact lens, the lens will be more steeper and the sagittal height of the contact lens will be increased accordingly. So remember one more thing about the diameter of the contact lens, and that is in RGPs, the average diameter of the contact lens in RGPs, rigid gas permeable contact lenses, the average diameter is from 8 to 10 millimeter. right? And in soft contact lenses, it's 12 to 15 millimeter. This is the average values, right? So remember that the base curve is also called the BOZR, right? This is also called the BOZR. And what is actually the base curve? BOZR mean the back optic zone radius. This is called the back optic zone radius, which is BOZR, and it is also called the base curve. So what is actually the base curve? Let's learn about the base curve. Base curve is actually the radius of curvature. This is very difficult to understand and this is very difficult to teach, right? The base curve, radius of curvature, right? But let's see the BOZR, back optic zone radius. So first we have to learn about the optic zone. Remember, if this is the contact lens, for example, if this is contact lens, there are two different area of the contact lens. The central area, I marked this area, this is called the central area, and this is called the peripheral area. So in terms of contact lens, this central area is called the optic zone. The optic zone. This central area is called the optic zone, and this peripheral area is called the lenticular zone. The lenticular zone, right? So when we will study the base curve, we will actually talk about the central part of the contact lens, the optic zone of the contact lens. What is optic zone? Optic zone means the central part. One more thing. So we have discussed that when we will discuss about the base curve, we will talk about the central zone, the optic zone, and which part of the optic zone, either it is frontal part or it is the posterior part. We will discuss about the posterior part. This one, for example, if this is a contact lens and this is optic zone, the central one, so this is anterior side and this is posterior side. So while discussing about the base curve, while learning about the base curve, we are actually discussing the posterior side of the optic zone, right? So I hope you got the concept. So the base curve is the radius of curvature of the posterior surface of the optic zone of the contact lens, right? So if, for example, before learning about the base curve, let's learn about the basic concept of the radius of curvature on a circle. For example, this is a circle. This is a bigger circle as compared to this one, and the smaller circle, the bigger circle, and the biggest circle. We have three different sizes of the circles. So what is the concept of the base curve? You know very well that base curve is actually, if we discuss in a smaller circle, actually this line is representing the base curve. So you see, if the circle is small, the base curve is small. As you can see, this line, this blue line is actually representing the base curve. So we conclude that if the circle is small, the base curve is small. If the circle get bigger, so you see the line is bigger now, right? So we conclude that if we increase the size of the circle, the base curve is actually increasing, right? So we increase the base curve. And in the biggest circle, you see the base curve is largest than the ever. So we conclude that in a smaller circle, the base curve is small. In a bigger circle, the base curve is somehow larger now. And in the biggest circle, the base curve is getting increase and increase, right? So let's learn about the contact lens now. So consider this circle as a contact lens, right? So we are considering that these portions as the contact lens. These red circled, which I marked, is we are considering this portion, this red portion, as a contact lens, right? This red zone is a contact lens. And the biggest circle, you see. So now let's get the basic concept and actual concept of the base curve. Circle number 1, circle number 2, and circle number 3. In circle number 1, which is smaller, the base curve is, for example, 8 millimeter. For example, in a bigger circle, the base curve is now 9 millimeter. In the biggest circle, the base curve is 10 millimeter. These are supposed value, as I told you, right? So you see, from here, from this point to this point, the base curve is actually increasing. So now let's extract the actual concept of the base curve. You see, at this point, at circle number 1, the base curve was smaller, decrease, and when we are moving from this point to this point, the base curve is actually increasing, right? 8 mm, 9 mm, and 10 mm. And when we are increasing the base curve, you see the steepening of the lens is getting flatter. At 8 mm base curve, the base curve was, or the contact lens was more steeper, right? And when we increase the base curve, the lens is getting flatter. And as we are increasing the base curve, the lens is getting more flatter. So as we are increasing the base curve, you see the lens is getting more and more flatter, right? And if we go from here to here, we are decreasing the base curve. You see 10, 9, and 8 mm. And as we are moving to this side, decreasing the base curve, the lens is flat, the lens is less flat, and lens is least flat. So we conclude that if we increase the base curve, the lens is getting more and more flatter. And if we decrease the base curve, lens is getting more and more steeper. So now let's connect the different parameters, the base curve and the diameter and the sagittal height, with each other. Let's find the correlation of these 3 parameters, right? So we will find that if I increase the diameter, how this increase in the diameter can affect the steepening and flattening of the contact lens, right? Or if I increase or decrease the base curve, how this increase or decrease in the base curve can make a contact lens more flatter or more steeper. Or what if I increase or decrease both at the same time, right? How these parameters can affect the steepening or flattening of the contact lens, the fitting of the contact lens actually, right? So we have concept that if I increase the diameter, this upper arrow is actually representing the increase in the diameter, right? So if I increase, for example, if I increase the diameter of the contact lens, my contact lens will be more steeper. You have the concept, right? And for example, if I increase the base curve, right? If I increase the base curve, my lens will be more flatter. So now the second is, if I decrease the diameter, if I decrease the diameter, the lens will be more flatter. The lens will be flatter. Now base curve, if I decrease the base curve, the lens will be more steeper, right? We have already discussed about these concepts. So what if I increase the diameter and also increase the base curve? So you know very well about the concept. If you will increase the diameter, your lens will be more steeper, right? And if you increase base curve, your lens will be more flatter. So if you increase both, there will be no any effect on steepening and flattening of the contact lens. Your lens will be look like the same, right? There will be no any flattening, there will be no any steepening of the contact lens. If you increase both the diameter and the base curve in a certain amount, right, then there will be no steepening, there will be no any flattening of the contact lens. And next is, for example, if you increase the diameter but you decrease the base curve at the same time, you are doing this phenomena at the same time. At the same time, you are increasing the diameter but you are decreasing the base curve. So by increasing the diameter, the lens will be more steep, and when you will decrease the base curve, right, your lens will be more steep. So we got the concept that if at one time I'm increasing the diameter, at the same time I'm decreasing the base curve, my lens will be more and more steeper, right? And the last thing is, if I am decreasing the base curve and at the same time I am increasing the base, in this case I'm decreasing the diameter, and in this case I'm increasing the base curve. So you know very well that if you decrease the diameter, your lens will be more flat, right? And if you increase the base curve, you decrease the diameter, lens will be more flat. If you increase the base curve, lens will be more flat, right? So at the same time, if you are decreasing the diameter and increasing the base curve, your lens will be more and more flatter. So finally, let's discuss about the rule of thumb in contact lenses. For example, we have dia and base curve. Rule of thumb is actually, for example, you know very well that if you increase the diameter, the lens will be more steeper. If you decrease the diameter, lens will be more flatter. We have concept now, right? So for example, I want to increase the diameter of the contact lens, but I do not want my lens to get more flatter or more steeper. I want my lens to be the same. I want to increase the diameter, but I do not want any flattening. I do not want any loosening or tightening, right? So what will I do? So you know very well that I want increased diameter. For example, I have 11 millimeter of diameter right now, but I want to increase. I want to go at 11.5. But when I'll go from 11 to 11.5, actually I'm increasing the diameter. And when I will increase the diameter, the lens will be more steeper. But I do not want any steepening in the contact lens. So what will I do? That follow the rule of thumb. Whenever you will increase the diameter of 0.5 millimeter, remember I'm giving you the concept of the rule of thumb. So when I'll increase the diameter of the contact lens 0.5 by 0.5 millimeter, I have to increase the base curve by 0.3 millimeter. You know very well that whenever you will increase the diameter, your lens will be more steeper, right? And when you increase the base curve, your lens will be more flatter. So in this case, increasing the diameter, your lens is getting steeper. By increasing the base curve, your lens is getting flatter. So this is actually neutralizing each other, right? So there will be you have your desired diameter, but there is no any steepening or there is no any flattening of the contact lens. So I hope this is all clear about the different parameters and their correlations of the contact lenses. And in the upcoming videos, we will discuss more and more about the contact lenses. So we'll see you in the next videos.